Hello again. We learned how to use Mole Island to convert moles to grams, things, and gas volume. But it's important to note that that is for one substance only. What happens when we're comparing multiple substances in a chemical equation? When we look at a chemical equation such as this, we might say, I only have 2 grams of oxygen. How much water can I make? Or I need 2 gallons of water. How much hydrogen gas do I need? These calculations are called stoichiometry, which literally means element measure. The coefficients in the chemical equation shows us the ratio of elements in the chemical equation. And remember, chemists would rather talk about moles than molecules. So we're going to talk about moles. That means that 2 moles of hydrogen gas react with 1 mole of oxygen gas to make 2 moles of water. Now that I have shown you how the moles of one substance compare to the moles of another substance, let me show you how to put together 2 mole island maps so we can create a stoichiometric map for our calculations. Here we have 2 mole islands put together, one for substance A and one for substance B. And as we said before, we can compare the moles of one substance to the moles of another substance in a balanced equation. And we're going to do this by using the coefficients from the balanced equation, creating a mole ratio, and multiplying by that mole ratio. A mole ratio is simply a ratio of the elements in a balanced chemical equation and their coefficients. So we can have a ratio of hydrogen to oxygen, and the ratio would be 2 to 1. But it doesn't have to be that way. It can be any way you want to make up these ratios. It could be oxygen to hydrogen, and we have 1 oxygen to 2 hydrogens. It could be 2 waters to 2 hydrogens. And the way we figure out which one's on top and which one is on the bottom is using the factor label method. So let's do a quick example of using the factor label method to decide how to make our mole ratio. So here from the equation you can see that 2 moles of hydrogen react with 1 mole of oxygen to form 2 moles of water. But what if I only had half a mole of hydrogen gas? Then how much oxygen gas would I need? Well, using the factor label method, we need to get rid of our hydrogen, so they'll go on the bottom so it'll cancel out, and then we can put our oxygen on top, and then we plug in our coefficients, 1 to 2, and when we multiply that out we get 0.25 moles of oxygen is needed to react with half a mole of hydrogen, and that would actually make half a mole of water. So I just want to show you algebraically why that works. Remember, in algebra we'd set up 2 ratios and cross multiply. So we have 1 mole of oxygen for 2 moles of hydrogen. How many moles of oxygen will we get if we have half a mole of hydrogen? And we cross multiply, we get 0.5 times 1 equals 2 times question mark, or you can make that an x, and that's 0.5 equals 2 question mark. We divide by 2 on both sides, and we get the same answer. 0.25 is our question mark, which was the oxygen, just like we got up here. Okay, so now I know how I can convert the moles of one substance to another, but why do I have all of these things from Mole Island? Well, they may not always give you moles. They may say I have 13 grams. How many molecules do I need of the other substance? And then, as we explained in Mole Island, when we go to moles, we divide by molecular weight to go from grams to moles. Then we would convert, multiplying by our mole ratio to go over here, and then to go to things, we would multiply, and over here it's Avogadro's number. So that is how we would use the 2 Mole Island maps put together. So let's do a problem. How many liters of hydrogen gas is needed to make 30 grams of ammonia? So the first thing we want to do is get a balanced equation. So we start with nitrogen gas plus hydrogen gas gives us ammonia. And to balance it, we need to put a 2 in front of there, so we have 2 nitrogens, and then we have 6 hydrogens, so there we have 6 hydrogens. Now we're balanced. Okay, we're given 30 grams of ammonia, and we're asked to find out how many liters of hydrogen gas is needed. So let's go to our map and figure this out. I'm going to put my balanced equation at the top. So here's my balanced equation, and just to keep everything equal, my ammonia is on this side, so I'm going to keep my ammonia on this side. And we're looking for hydrogen gas, which is on this side, so I'll put it over there. And we're starting with 30 grams, so let's put that right on our map. 30 grams is where we're starting, and we want to end up with how many liters, which is volume of gas, of hydrogen gas. So our map is going to look like this. We're going to go from grams to moles, moles to moles, and then moles to volume of gas. And of course this is at standard temperature and pressure. I didn't say that, but that is the only way we can use mole island with gas volume. So that's the way it's going to be. So to go from grams to moles, we are going to divide by the molecular weight of ammonia, because that's the side that we're on. So let's go do that. Okay, the molecular weight of nitrogen is going to be, nitrogen is 14 plus 3 times 1 for the hydrogen. Nitrogen plus hydrogen is going to equal 17 grams per mole. So we are going to take our 30 grams of ammonia and we are going to divide by 17 or multiply by its reciprocal, 17 grams per mole. So our grams will cancel out. We're left with moles, which is what we want, and that will be 1.8 moles of ammonia. Okay, so we're at 1.8 moles of ammonia. And you can see we're still on our ammonia side. And now we are going to go over to the hydrogen side, and we're going to do that by multiplying by the mole ratio. Okay, so let's multiply by our mole ratio. And remember, we want to get rid of our ammonia, and we're going to hydrogen gas. Our ammonia has 2 moles there from the balanced equation, and our hydrogen has 3 moles from our balanced equation. So when we multiply that through, our ammonia will cancel out. We'll be left with hydrogen gas, and that's going to equal 2.7 moles of hydrogen gas. Let's go back and plug that in. 2.7. And we're on our hydrogen gas side. So now we need to convert that into volume, and we're going to do that by multiplying times 22.4. And just a reminder, you can go back to the mole conversion confusion to explain a nice refresher of how mole island works if that's still confusing you. So we have 2.7 moles of hydrogen gas, and we are going to multiply by 22.4 liters per mole. And our moles cancel out, and we get 60.48, or just 60 in sig figs, liters of hydrogen gas. Okay, just a quick review. It's helpful to put your balanced equation on top and then mark down what is substance A and what is substance B. And then you should plug in what you're given, which could be anywhere on the map. Let's say it was grams. and then circle where you want to end. Let's say it was grams of substance A. And then you should just go from what you're given through the map to what you want, and it's that easy. Hope that helped.